Hello friends, this video on Electrochemistry part 33 is brought to you by examfear.com. No more fear from exam. Secondary batteries. As I told, this kind of batteries you must be seeing in the car. This is used in the car or inverter in the home. And this is used in mobile phones. Also, if you see the laptops, they have this kind of batteries. So they can be recharged by passing the current in opposite direction. And actually a good secondary cell, it can undergo a large number of discharge and recharge cycle. If you see a given battery will have fixed number of recharge and discharge cycle. That's why even if you buy a rechargeable battery, you use for 2 years, after that it doesn't work, it stops working, because every battery has a fixed number of charging and discharging cycle, right? So they are a little costly. Initial cost is pretty high. Initial cost is high, but overall cost is less. Why? Because the same battery is used for a longer period of time and they have low impact to environment. Why? Because you're using the same battery for a longer period of time. Correct? So the examples are the lead storage battery used in the vehicles, or nickel cadmium battery, or the lithium ion battery which is used in the mobile phones. Correct? So we'll discuss about these batteries. Now we'll talk about the lead storage battery. So these are the most popular rechargeable batteries used mostly in the vehicles. Here my anode is lead and cathode is lead oxide, PbO2, and my electrolyte is 38% sulfuric acid. Correct? Now if you see the discharge cycle, I can show you the discharge. When you talk about the discharge reaction, my anode, if I want to write, oxidation will happen. So lead will become lead sulfate and 2 electrons will come. So if you see, Pb become Pb plus 2. And at cathode, reduction will happen. My PbO2 will take some H plus ion, some sulfuric acid, take some electrons and take some SO4 2 minus ion from again sulfuric acid, and this will form PbSO4 plus 2 water molecule. Correct? This from plus 4 to plus 2. So reduction happened. Discharge, again the same reaction will be reversed. If you want to write the overall reaction, it will be lead plus PbO2 plus 4H plus again from sulfuric acid plus 2SO4 2 minus again from sulfuric acid will give me 2 PbSO4 and 2H2. That is the reaction. Correct? So each cell is 2.2 volt each cell. So now generally they are either used in 3 cells or 6 cells. So if they're using 3 cells, then the total volt will be 3 into 2.2, almost approx to 6 volt. Or they are using 6 cells, 6 into 2.2, almost approx to 12 volt, because if you add in series, there's some voltage drop also, right? So since you can recharge it also, so it is also a voltaic cell. It is a voltaic cell when you are discharging it, and it is an electrolytic cell when you are charging it. During discharge, it acts as a voltaic cell. During discharge, it acts as a voltaic cell. It acts as a source of energy. During charging it back, it acts as an electrolytic cell. Then we'll talk about the nickel cadmium cell. Again, it was created by Wagner Junger from Sweden in 1899. It has longer life than lead storage cell, but it is expensive to manufacture. It is expensive to manufacture. Correct. So here we have anode and cathode. So at anode we have cadmium, and we have cathode, we have nickel. Correct. So anode we have cadmium and cathode we have nickel. And it is also a rechargeable cell. So at anode oxidation will happen. I'll show you. At anode my oxidation will happen. So what will happen? My cadmium will convert into Cd plus 2. So it will take some 2OH minus, it will become CdOH2 plus 2 charge. Give 2 electrons. We talk about cathode. My cathode reduction happens. And in this what will happen? Again, my nickel is my first guy here. So nickel NiOH. NiOH actually. Let me write here. NiOH. Yeah. This, when gets 2 molecule of water plus 2 electron, it becomes NiOH2 and 2OH. You see, this is used here. If you want to write the overall reaction, that will be 2 NiOH plus here cadmium plus water molecule here. It will give you 2 NiOH2 plus CdOH. That is the reaction mechanism. Correct. So nickel cadmium battery was popular, but 1990s it lost its market share to lithium ion battery. We'll not discuss lithium ion battery, but just understand it was popular and it has lost its share in the market. The next. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.